Welcome. The topic of this video is dynamic memory allocation. Sometimes amount of data cannot be predicted beforehand and number of data items keeps changing during program execution. We have seen such situations in many of the previous lectures. Example, search for an element in an array of n elements. One solution, this is what we did to handle this situation before, is that find the maximum possible value of n and allocate an array of n elements. This is wasteful of memory space as n may be much smaller than the maximum possible value that it can take in some executions. Example, maximum value of n may be 10,000, but a particular run may need to search only among 100 elements. So 9,900 locations are not utilized. And so memory is wasted in such cases. In this video, we'll explore a better solution, which is dynamic memory allocation. Know how much memory is needed after the program is run. Example, ask the user to enter from keyboard. So in examples that we saw before, like in previous lectures, earlier lectures, we first allocate an array of a certain size, let's say 100, and then ask the user for the actual number of entries. And then the user enters, let's say 30 or something. But the array allocated is of size 100. So the actual number, the number of memory that is needed can be known only after the program is run. It's only after the program is run that the user enters through the keyboard the actual number of entries to be stored, and we know the amount of memory. Here, in dynamic memory allocation, when the program runs, we will know how much memory is needed, and then dynamically allocate only the amount of memory needed. C provides functions to dynamically allocate memory. These are the functions that C provides. Let's go through them briefly. Malloc allocates requested number of bytes and returns a pointer to the first byte of the allocated space. We'll discuss malloc at length later in this video. Calloc allocates space for an array of elements and initializes them to 0 and then returns a pointer to the memory. Free frees previously allocated space. Freeze means, after you call the free function, those spaces are not reserved by the program anymore, and those are returned to the system. Realloc modifies the size of previously allocated space. In this video, we will only do malloc and free. A block of memory can be allocated using the function malloc. What does malloc do? It reserves a block of memory of specified size and returns a pointer of type void. We'll soon see an example. The return pointer can be typecasted to any pointer type. General format. You declare a pointer of a certain type, so type star p, and then p is equal to type star, this is a typecasting, then a call to malloc, and on the argument of malloc is the number of bytes that you need to allocate. So you pass the number of bytes that you need to allocate to the function malloc. Malloc allocates those many bytes and returns a pointer to the first byte of this allocated block. This block is always, contiguous in memory. So if you call malloc with argument 10, malloc allocates 10 contiguous bytes in memory and returns you the address of the first of those 10 bytes. Now so malloc returns an address, so it's a pointer. But what is the type of that pointer? Now the malloc does not know the type of the variable that we will use that we will store in this allocated memory. So malloc just returns a void pointer, and that void pointer can be typecast to any type. Here, malloc is used to allocate space enough to store 100 integers, and then to assign an integer pointer the address of the first of those 100 contiguous locations to store integers. Now the argument here of malloc is 100 times size of int. Yeah, size of int, the size of operator returns the number of bytes that int occupies in your machine. So it gets multiplied by 100, and that is the actual number of bytes that you will need to store 100 integers. Those many bytes are allocated, and malloc returns a void pointer to the first of those bytes, which is after suitable typecast is assigned to p. So here 400 bytes of space, it's under the assumption that int occupies 4 bytes. Yeah, p is a variable, it has its own storage, and what gets stored in this storage is the address of the first byte of this sequence of 400 bytes of space. Some more examples. CPTR, is a character pointer. First you use malloc to store 20 bytes, and then the void pointer that malloc returns pointing to the first byte of these 20 contiguous bytes is, after suitable typecasting, assigned to CPTR. The pointer type could be, pointed to a user defined type as well. For instance, if you have a structure by the name stud, then you can use malloc to allocate sufficient memory to store 10 variables of that type. 10 times size of struct stud will give you the actual number of bytes that you need to allocate. Malloc will allocate those many bytes and then return the address of the first of those bytes, which after suitable typecasting can be assigned to SPTR, which is a pointer that points to a structure variable of type stud. Always use size of operator to find number of bytes for a data type, as it can vary from machine to machine. Struct stud may take different number of bytes in different machines. Int may take different number of bytes in different machines. So it's always advisable to use size of operator rather than writing directly in the program the number of bytes while calling malloc. Points to note: malloc always allocates a block of contiguous bytes. The allocation can fail if sufficient contiguous memory space is not available. If it fails, malloc returns null. If int star malloc 100 times size of int, if this call to malloc fails, it will return a null pointer which will be assigned to p by this assignment operation, and then p can be compared with null, and if p is equal to null, that implies that the call to malloc failed, in which case a suitable message can be printed, and then the program can be terminated. Once the memory is allocated, it can be used with pointers or with array notation. This is because the memory is contiguous, so any pointer that points to the first byte of that memory can be used to access the entire memory block. By that block can be traversed using pointer arithmetic or using array notations. For instance, here p is an integer pointer, integer n is read through the keyboard, and then size sufficient to store n integers is allocated using malloc, and the pointer to the base address to the first location of this block, the first byte of this block after suitable typecast is assigned to p. And then individual elements, integers of this block can be accessed using array notation like p within bracket, square bracket I, or you can use pointer arithmetic and access it using star p plus 1, star p plus 2, and so on. So both notations can be used to access the individual elements. Here is an example that taking heights of a variable number of students and then computes the average height and prints it. This scanf function reads the number of students, and then you use malloc to allocate space that is sufficient to store heights of n students. Yeah. So each height is a float, so the number of bytes you allocate is n times size of float. And a base address of this block is assigned to height after typecasting to float star. Then n heights are read in by scanf using the array notation height I. The ampersand height I is exactly the address of the ith floating point variable in this block of n floating point numbers. And then you can add all these heights and assign the sum to a variable of name sum in this for loop. Yeah. And there also you can use array notation to access the individual floating point numbers. Finally, you compute the average and print it out. Then you can free this memory by a call to the free function, free height, and then you return to the caller program. Releasing the allocated space, free. An allocated block can be returned to the system for future use by the free function. General syntax, free ptr, where ptr is a pointer to a memory block which had been previously created using malloc. Note that no size needs to be mentioned for the allocated block. This is curious. ptr is a pointer that points to the first byte of a block of memory, and free is expected to free up the entire block. But ptr does not seem to contain the information about the size of the block. Yeah. So how does free know how many blocks to free? Well, that information the system remembers, and free has access to that information separately. It doesn't have to be passed that information explicitly in the form of an argument. Can we allocate only arrays? Malloc can be used to allocate memory for single variables also. For instance, p equal to int star malloc size of int. Allocate space for a single integer, which can be accessed as star p. However, this is not a fundamentally different kind of allocation, because single variable allocations are just special cases of array allocations, a special case of array allocations, because a single variable is just an array with one element. Mallocing array of structures. Here is a structure variable, which is named person, and it stores some information about a student, name, roll number, SGPA, CGPA, etc. Then you define a pointer variable named student, and the type of student is person star. So student holds a pointer to a structure variable of type person. Then you read the number of students through the scanf function. You use malloc to store enough memory to reserve enough memory to store the information about n students, that is enough memory to store n variables of type person, n times size of person, many bytes, and then after suitable typecast, a pointer to the first of that block of memory is assigned to student. Then you can in a for loop, fill the student information as the user enters those information through the keyboard by scanf functions, by calls to scanf function. Okay. Static array of pointers. So here char star wm, capital M is a macro defined to be 10. So this defines an array of character pointers of size 10. So it's a static array as opposed to dynamic array. So its size is specified in the program itself. It's not a dynamically allocated array. It's statically allocated array. So in this program, a static array of size 10 is declared. And then each entry of this array is a character pointer. Now in this, after that, you read in an integer n through the keyboard. This integer n is going to be the number of strings that you will enter. Now, as I goes from 0 to n minus 1 in this for loop, you read one string. In each iteration of this for loop, you read one string through the keyboard and store it in an integer array of size capital N, which is again a macro defined to be 20. So you read a string and store it in word. Yeah. After that, you allocate memory that is long enough to hold the word, the string that you just read. Yeah. How many bytes do you need to allocate? Size of char. So let's say size of char is 1. So and the number of characters that you need to store is strlen word plus 1. This plus 1 is because we would like our strings to be null terminated. I mean, strings are always null terminated. We'd like our character array to be null terminated so that it's a valid string. Yeah. And then I copy the string that is currently in the array word into this array of characters that I just allocated. And I make use of the library function strcpy for that. After that, I run this for loop and print all the strings that I took in through the keyboard. This is an output. First you specify the number of strings, then you enter 4 strings, and then you print them out. This is the output behavior, and this is how you do it. What does it look like pictorially? When W is an array of size 10, fixed, irrespective of how many strings you enter later. In other words, irrespective of the value of this small n here. W is a array of character pointers of size 10. Now, in this example, small n is 4. Yeah, here. So you will enter 4 strings. The first string is Tendulkar. What you do is allocate an array of size how many? Tendulkar has 9 characters plus 1 for storing the terminal null. So you allocate a character array of size 10. Write Tendulkar followed by null there. And make W0 point to the first byte of this array. So this array is just long enough to hold Tendulkar and no longer. Similarly, the next string is Saurav. You allocate 7 bytes. That is just sufficient to store Saurav and the terminal null. And then, you copy Saurav into it and then make W1 point to it. So all these arrays, character arrays, are of different lengths because these words are of different lengths. But this array is of a fixed length because it's not a dynamic array. It's length 10. Pointers to pointers. So what are pointers to pointers? Well, pointers are variables storing addresses. So they have a memory location. So pointers themselves have a memory location. And that memory location also has an address. And that address can be stored in another pointer variable. So what is the type of the second pointer variable? That is a pointer to a pointer. Yeah. For instance, a pointer variable that stores address of an integer is pointer to an integer. And a pointer that stores address of a pointer to an integer is a pointer to an integer. So here is an example. So here x is integer, p is an integer pointer, and q is a double pointer, which is a pointer to an integer. Int star star q. Now we assign ampersand x, which is an address of x, to p, and address of p to q. Now let's consider this printf statement. What does it print? Well, these three format specifiers separated by spaces. So what is the first number integer here that replaces %d? Well, the value of x, which is 10. How about this one? It's star p. So p contains address of x, so star p is value of x, which is 10. And this one is star q. Q contains address of p, so star p contains value of p, which is address of x. So star q is address of x, which is p. So star of star q is star of p, which is x. So 10 again. So you get 10 space 10 space 10. This is what is printed. Allocating pointer to pointer. So let's say p is of type int star star. That is, it's a pointer to an integer. Now you can allocate enough space to store 3 integer pointers. Yeah. Now it's an array of 3 integer pointers using malloc function, and you pass 3 times size of int star to malloc. This is exactly the number of bytes that are required to store 3 integer pointers. And the address to the first of those bytes is returned by malloc. And then it's assigned to int star star. You used int star star type casting. Why do you do that? Well, the type of the data stored in this array is what? It's int star, 3 of them, 3 int stars. And so what you need to assign to p is a pointer to int star, which is int star star, which is what you do. We will use pointers to pointers to create dynamic arrays. So we will write the same program that we wrote using static arrays of pointers by using dynamic arrays of pointers. So we declare w to be a double pointer, character double pointer, char star star w. Okay. Now you take in the number of strings that you will enter, store it in n. Then you allocate memory that is just enough to store n character pointers. Yeah, you allocate that memory and then assign the base address of that memory to w after suitable typecasting. Excuse me. Yeah. Let's compare this with what we did earlier. Earlier, w was a static array of a fixed size, and it could potentially be much more than the actual number of strings that you would enter. Now, we are allocating memory dynamically. So now w will point to a block that is just enough to store n many character pointers. The rest of the code is the same. In this for loop, you take in n strings. In an iteration, you store them in the character array word, then allocate enough space to hold that string, copy the string that you had taken in and which is currently in this array word into this newly allocated memory, and finally in this for loop you print all the strings that you took in. And this is a sample input output. But what does it pictorially look? So these arrays are of different lengths because these arrays were dynamically created and created to be with just so that they are just long enough to hold these strings, but no longer. This now has size exactly n, which is 5 in this example. 5. 5. Earlier it was 10 always, but now we allocated this array dynamically here, so it has the space for storing exactly as many character pointers as is the number of strings that we later enter. Thank you.